Hello and welcome to lesson 1 of week 8. In this lesson, we are going to look at object-oriented programming. My name is Mildred. Object-oriented programming is a way of writing and organizing code around the concept of objects. And what it does is group related properties and behaviors into objects. And we use classes as blueprints. Now, when we have classes, it allows us to define functions within them. And we call these functions that are defined within classes methods. For instance, we can create a person class that defines the characteristics and the behavior of a person. When we say an instance of a class, it's like an object that is built from that blueprint class. And this object contains real data. So let's look at a class like a questionnaire or a form that is blank and distributed in a hall. And let's look at the object as the questionnaire returned when they are filled out. So we look at a class like an empty form waiting to be filled out, and the object has a form that is already filled out. So an object is like a real world thing. It has attributes. The attributes are called data. It has behaviors, and the behaviors are called functions or methods. Object-oriented programming makes it easier to make your code modular, reusable, and easier to maintain, especially when you have large or complex programs. And we're going to see a complex program in lesson 2. Now, there are principles of object-oriented programming that we're going to look at down the line. Encapsulation, which is the building of data and method inside an object, and then we'll hide the internal details. Like, for instance, we have the TV remote. You can use the remote, but you don't have to know how it works internally. It's hidden from you. It's sealed. You have to take it to someone who is repairing it to open to see something is wrong inside. But the whole details of the internal workings is hidden. Then we have inheritance, which is like creating a new class that reuse or extend the features of an existing class. For instance, when we have a car as a class, and then we have a new class called electric car. The electric car will extend the behaviors of a car. Electric car will have, let's say a car has methods or behaviors or properties like the model, the make, the brand, the color, the weights. And so when you take electric car, you want to extend these behaviors. So you're going to inherit from the car class. And so we have what we call polymorphism, and is the ability for different objects to respond to the same method in a different way. So for instance, when I say I have a method called draw, and when I say call the draw method, it does something. But person 1 can implement draw as drawing a circle, person 2 can implement draw as drawing a triangle. So whatever it draws is different. The way it's implemented is different. And then we have something called abstraction, which focuses only on the essential features while it hides unnecessary details. Like when you are driving a car, you don't worry about how the engine fires. So that feature is not your problem. Your problem is driving the car right and not getting into an accident, right? So that's like the abstraction. So all the unnecessary details is not on your dashboard. You don't see the details of how the engine is firing, but you see details that are necessary and that you need for your car maintenance or to keep you safe. So let's look at an example of class. Let's say, for instance, we want to create a class called person, and from this person class we want to create objects. These objects are going to be different people, right? And so the person class will be a blueprint for creating objects. So this is easy when we want to create a registration form, for instance, and I just create a person class. And this class have several methods or functions within them. We know that when people come to register on the site, the people have the same characteristics but different values for these characteristics, or they have the same some behaviors or methods. Let's call these properties, or let's call these characteristics properties. So anybody that comes will either belong to one gender or one sex, will not belong to two sexes at the same time. Anybody that comes has a name. The person that comes has a race. And let's say these are form fields that we are collecting for this app. We create a class in Python using the class keyword, and then the name for the class starting with uppercase by convention, and then a colon, and then in the body of the class we begin to define the attributes. One of the first things that you will define is a method called the init method. Now when we say method and function, they are the same thing. The only difference between them is where they exist. A function exists by itself. A method is a function that is created inside a class. So we define it the same way. We use a dunder method init, and this init method is invoked automatically when an instance of a class is created. Whenever we create an object, this is invoked. Now in the parentheses here, we define parameters. The first parameter you always have in a method within a class is self, and then you define other properties that we want to have, other attributes that the person has. So we want to collect the name, the sex, and the race. You can collect many details. You can even collect the age from here, but let's deal with these three first. And then when you do that, you want to create the value for this. So self.name. So when we say self, we just refer to the object itself. Like if you're coming from JavaScript, you have the this keyword, and when you use this, you're referring to the object itself, right? So self.name is equal to name, and then we'll say self.sex is equal to sex, self.race is equal to race. That is where we stop. Now we've defined this. We have two types of attributes. We have the instance attributes and the class attributes. All of the attributes we defined here are called instance attributes. For an instance attribute, all people have a name, a sex, and a race, but the values for each person differ. Let's say, for instance, let's say we are building this, people registering are definitely alive before they registered, right? And so we want to put a default value called status. I'll say status is equal to alive. Now this attribute is called the class attribute. You define it just immediately after the class definition here, and then you define class attributes. You can define several class attributes. One of the property of this class attributes, or one of the thing about it, is that it applies to every instance of the class. It's an automatic value that everybody has until you change it. So everybody who registers is alive until maybe you have a notification that somebody passed and you want to update their record to deceased, and then you call that attribute and give it the new value for that instance of the class when you create an instance. So this is called the class attributes, and this is called instance attributes. So let's create objects of a class. When they say you instantiate a class, you're creating an object of a class. So outside of the class definition, we want to create a variable. Let's call this variable P1. This P1 is a variable that will hold the object from this class. The object is now the first person. How do you instantiate a class? You just call the class name. In a pair of parentheses, you supply the values for all of for this init method, you see, for all of the parameters that this has. So the values we want to have here is, let's say the first person is Alice Jones, and the sex of Alice is female, and let's say the race, let's just use human. And then I'll copy this, and I want to do the same thing. Let's create 4 people. So we have 4 people here. That's 4 persons. These are called objects. P1, P2, P3, P4 are objects. So now you see how this class is a blueprint from where we created different people from. So if you have an object-oriented programming and you're in your back end for your application, and when people register, people come to your site, and let's say it's a sign-up form and they register, and this person class is now called to create objects for each registered person before you get those values and pass it to your database or wherever you're storing this. So let's print out and see what it holds. So when you want to print out the value of an attribute for each of the objects, so we can say P1 is the object that holds a person. So let's say P1.name. Let's see who is in P1, right? And then let's print out P1.sex also, and let's print P1.race. We'll do the same thing for P2, or let's do the same thing for P4, and then we'll see that everything is printed out. So whenever you want to print out the value for the properties, you just use the name of the objects dot the name of the property. And so when I run, I have Alice Jones, female human, Diana Prince, female human. Now we say everybody is alive. Let's do this P1. So let's print this again with the status there. So because this class attribute applies automatically to everybody with the default value alive, let's say Diana Prince is deceased. We can come here and say, so we call that property and give it a value. So whenever you call that attribute status, you want to give it the new value. So every time you want to change a value for one of the property or one of the attributes for an object, you just use the object name dot the name of the attribute or the name of the property, and then the new value. So this person is deceased, and I'll say deceased. And when we print P4 again, you'll see that the status will change from alive to deceased. So we have Diana Prince, female human, deceased. We have something we call instance method. And when you talk about instance method, we're talking about functions that are created inside of a class. So objects that we create inside a class are called instance method. It is defined like this, just like we define a function. So let's say def. Let's say we want to have a function or a method here, introduce, and whenever you do this, you must have the first parameter as self. Every time you have a method within a class, your first parameter has to be self. If you don't have any parameter to pass in, you just have to leave only self there, like that. So we want this to just return something. Let it return the details of the object. So let's say self.name, like this. We want to return this. So we want to return this. And so when we call this, let's say, I'll delete all of this. I'll say, I want to call the instance method. So what I'll do now is to say p1 dot, the method is called like this with a pair of parentheses. Now there is no argument to pass because there's no argument here. So when I print this, I'm going to get the introduction, hello, my name is, with a name for p1. If I change this to p3, I'll get the value stored in p3. Hello, my name is Charlie Brown, I am a male human, like that. Let's look at another instance method that will help us to look at the datetime module. Let's say def age, for instance, and the first will be self, and we want the arguments to be the date of birth for the person. When we looked at module last week, we saw how we can import functions from another module or another file. We have a datetime module that has different methods, functions, or classes, and we want to just take the datetime from the datetime. So sometimes when you have a module, you just want to call only one function from that module. You just call the function used from the name of the module. So I'll say from datetime, I want to import datetime. I can decide to just write import datetime alone, but then I imported datetime and I have to call datetime dot the name of the function dot the name of the method or the name of the class or the name of the method is going to be long. So I just import what I need. So from datetime, import datetime. Now what I want to do with this is I want the argument that is passed in when this instance method is called to be a date, and I want to format this date so that it calculates the year or it calculates the age of the person. So I want to store a variable today. Let's calculate today's date. The datetime module has this method today, and this will give us the current date today. We want to get the birth date for the person, and this birth date should be equal to, we want it to be this date of birth, but we want to format it to a particular format. So let it fit the today's date. So we want it to be a 4-digit year, a 2-digit month, a 2-digit day, and something like that. So write the day is going to be, we'll use another method dot strip time, and now we'll pass in the original dates that the user will pass in, and now we want to put the format we want it. So put percent uppercase y, we'll percent lowercase m, and then percent d. So this is the format we want that date to be converted to. And once this is done, we want to calculate the age. So for the age, we want to calculate it down to subtract both ages. Subtract when the current year minus the year of birth, the month and the day minus the current month and day. See which one is higher. If for instance, the person was born in December of 1985, you don't want in January of 2025 the person turns 40. You want the person to turn 40 in December. So we'll do the calculation like this. Today dot year minus birth year. So we have the birth date there. The birth date dot year. So we're taking the year of birth, we're subtracting it from the current year. Then we're going to subtract this from. Let's use a comparison. We'll compare today's month and day to the birth month and day, and we're going to subtract this when if it's less. So today dot month, today dot day. So we'll compare it with is less than birth date dot month birth date. So like this. So this will calculate the age. And what we want to return now is, let's just the text. We want to return self dot name is, we want to return the age. This age calculated, this age is, so see how we formatted the date that is passed in. But before we go further, let's just check. So we'll say p3.age. Let's apply the date of birth for p3, and we'll say 1995. Let's use May 17th, like that. And when we run this, we will get the age of Charlie Brown, which is person 3, to be 30 years old. Okay, so you see how we call this method. But this is not Pythonic. If we say, for instance, I want to print out p3 alone without any of the attributes, I'm going to get the object reference like this. But this is not what we want. What do we want to do? we want to have the Dunder method string like this. So we have meta classes and magic method, and we can reset them to see. We change this to string, and once this is done, it's going to introduce, when we say P3, like this print, it's just going to introduce the P3. Hello, my name is Charlie Brown. I am a male human. What we have there. So you can use this, and sometimes you see this instead of the string there. And the difference is just, one is for end users, this is for like developers for debugging. You want to remove ambiguity in this, and for the string you just want it to be human readable, you want it for readability, and the audience is different, but it's going to print out exactly the same thing. And if we don't have the string, or it looks for that. If it doesn't have that, then it just prints out the object reference. So this is where we end this lesson. In the next lesson, we're going to go deeper to look at different concepts. We're going to look at inheritance. Thank you, and see you in the next lesson.